Hello guys, so in this video we'll be discussing recursion. So I'll be talking of everything you need to know in order to implement recursion in CP or in problem solving. The only prerequisite for this video would be to know that how functions work. So how do we call functions and how we can return values from them. That's the only prerequisite you need for that. If you don't know how to call functions and how to return values from a function, I think you should firstly watch those videos and then come back to this. And I'll also be talking of the C++ implementation for the same. So with that, let's get started. So let's try to understand what is recursion. So for that, let me take a very simple example. Let's say you are a person, right? Which you definitely are, and you have a big company, and there are a lot of employees in your company, right? Now I come to you and I ask you what is, let's say, 3 to the power 10 maybe, right? So you are a very lazy person. So you say that I don't want to calculate it. Don't want to multiply 3 10 times. So what you can do? There are different ways of doing it, but yeah. What you try to do is that you say that okay, I know that 3 multiplied by 3 10 times, right? Or 3 to the power 10 is actually equal to 3 into 3 to the power 9, right? So I want my subordinate to calculate this value. Once he gives me that, I'll just multiply these two numbers. Cool. So you ask your subordinate that okay, tell me what is 3 to the power 9. So he also is a lazy person like you. He also doesn't want to calculate it. So he gives it further. So he says that okay, I'll calculate what is 3 into 3 to the power 8, but at least provide me 3 to the power 8. So he gives that to his subordinate. Okay, so he asks that what is 3 to the power 8. Now he also is a lazy person, so he says that okay, I'll calculate 3 into 3 to the power 7, but I need to get this value. So he gives it to his subordinate, then he also gives it to his subordinate and stuff, right? So it keeps growing until I reach to a point where the value which I want to calculate is actually 3. So what would happen is that he'll say that I can calculate 3 into 3 to the power 4. Then he'll give 3 to the power 4 as 3 into 3 to the power 3. Then the other person would say that okay, I'll calculate 3 into 3 square. Then he'll say that okay, I'll calculate 3 into 3. Then he'll say that okay, I only have to calculate 3. So that's something stupid. I can just return it, right? So I'll say that 3 to the power 1 is actually 3 itself. Cool. So now he'll say that okay, so 3 to the power 1 is 3. So now I'll give a value 9. Now he'll pass this value 9 to its senior. So he'll get a value 9. Now he'll say 3 into 3 square is actually equal to 3 into 9. So that is 27. Then he'll give the value upwards. Now he'll get the same thing. Then he'll say okay, so 3 into 27 would be 21, and then okay, 27, 3, 21, 2, yeah, 6, 8, right. Okay, so it's 81. So then he'll give 81 to its senior. He'll say that okay, 81 into 3 is basically 243, and so on and so forth. You basically get that drill, right? So this is what recursion is. So what do we need to do in recursion? So in recursion, we fixate on the smaller problem. Like over here, I was focusing on just calculating 3 into whatever the remaining thing is, right? So this is a smaller problem for me. And then the remaining part of the problem, I delegate that to a children or to the same function, right? So I'll delegate this. Okay, so let me write down the pointers. So the first thing is breaking down the problem. The second thing is delegating it further. Okay, so what's the third thing? So the third or one of the most important thing is that you have to have a terminating condition. Over here, the terminating condition was that the person who was checking what is 3 to the power 1, right? What it could have been the case that he asked that okay, I'll calculate 3 into 3 like 3 into 3 to power 0, and then he asked further and then he asked further, but that would actually become an infinite loop, right? So we want to avoid such conditions. So there has to be a terminating condition. There should be a case that where the problem has become simple enough. Terminating condition. So there has to be a case where the problem has become simple enough so that it can be calculated by a single call. So over here, just calculating what is 3 to the power 1 was actually a very simple thing to do, right? So that was a simple problem. So we defined that as a terminating condition. And often terminating condition has a known value. Condition has a known value, right? Or something that is pretty easy to calculate. So over here, the known value was that 3 to the power 1 is actually equal to 3. Cool. With that, let's try to implement the same. So I'm having this Sublime text. Over here, I've made a method that is power. Let me try to code it up again so that it's easier for you to see as well. Okay, so firstly, I'll be defining a method, let's say power, and that would be returning me the value. So then I have two numbers, that is int and int x. So basically, I'm trying to, you know, calculate power of or n to the power x, let's say, right? That makes more sense. Cool. I'm trying to calculate n to the power x, but now I'm a lazy person. I don't want to calculate it. So I'll say that, okay, n to the power x basically means n into power of n minus 1, right? Power of n, okay, sorry, power of x minus n comma x minus 1. Cool. What next? So there's no terminating condition, right? So I'll have to say that if my x is equal to 1, if you just want me to calculate the value of n to the power 1, so that basically is n, right? So I can simply print n. Now from the main method, I want to calculate the power of 3 to the power 10. Let's try to run this up. Cool. So over here we get a value that is 59049. Let's try to change the numbers a bit. Let's say 4 to the power 10. Let's see. Okay, so we get this value. Although there's a better way of actually calculating the power, that is binary exponentiation. So we do have binary exponentiation for this, right? That I've already taught in a previous video that was related to mathematics. But still over here, I just wanted to make you understand that how recursion work. So this was a pretty intuitive example, I'll say. With that, I think recursion would be clear. Now, most of the times we'll actually be using complex ideas for that, but the approach exactly remains the same. So the thing has to be that we'll be fixating on a small problem, we'll be delegating the problem further, and we'll be having a terminating condition. So these are the three aspects for recursion that you need to know. Now, why are recursion important? Because there are a lot of problems which actually make sense to wherein it actually makes sense to break down the problem in such a way that you can solve the current problem and then delegate the rest further. So that's why recursions are important. Recursions are also important for advanced concepts like dynamic programming and also graph traversals. So let's say even if you're trying to traverse a tree or something like that, okay, traverser, traversing. Because in traversing, what you can say is that I want to focus on the current node, right? So what if you're traversing something? So you can say that I want to focus on current node and its children would be considered by my subordinates, right? So that's why recursion is a lot important. It's used in various type of things and various type of algorithms. However, the focus of this video was to teach you the concept behind it of how recursion takes place. So I think that is pretty clear. Now talking of the questions, so there are a lot of questions we can go over from lead code and code forces. However, that won't be covered in this video, else the length of this video is gonna get too long. So I'll be covering those topics in the other video. For this video, that was it. Cool guys, I hope you were able to understand the concept. If you still have any doubts, you can let me know. You can join the Discord server. We can have a doubt clearing session over there as well. Cool guys, thanks a lot. Bye bye.